Today we're going to be using what's called the elimination method. So you've already learned two ways to solve systems of equations. The first one was by graphing, which is great if you have a graphing calculator, but otherwise it's really long. The second one is called substitution. That one's really good if you have something that's solved for x or y. However, if you see what the problem on the screen looks like right now, this one's really hard to do using the substitution method. So we're going to use what's called the elimination method. And you might have heard this called the linear combination method. The other thing is that your book calls this the solving linear systems by adding or subtracting. All of those are the same thing, so don't get confused about the different names. So I'm going to ask you to solve this using elimination, and what we're going to do is I'm going to tell you the three things that you need, so to solve with elimination. And the first thing is many of the problems will do it for you, but not always. Sometimes they're not going to. So the first thing you need is you need to have all of your common variables, which means your x's and your y's are like variables. They need to be lined up. And you also need your equal signs lined up. So make sure that that happens. So your like variables need to line up, your equal signs need to line up, your numbers need to line up. So make sure that everything lines up properly. If things aren't aligned, then it's not going to work. The other thing you need is that whatever variable you choose to eliminate, x or y, you're going to always choose the one that is easiest, and the easiest ones are going to be the ones that have the same coefficient. Now, if you remember, the coefficient is the number in front of the variable. So if you look at the system of equations on the left, you'll see that the x's both have a 3 in front of it, which is a good start. The third thing that you need is you need the opposite sign. And luckily, the equations I gave you for this first problem all have that. So then once you have all that, the problem is actually pretty easy. We can eliminate the x variable. What we're going to do is we are going to take these two, add them straight down. So 3x minus 3x is going to be 0x, or you can just cancel them out. 4y plus 5y is 9y. I'm going to bring down my equals. 8 plus 10 is 18. Then I am going to solve by dividing both sides by 9. I get y equals 2. The next thing I need to do is similar to what we did in substitution, but I have to find my x by substituting the 2 back in for y. You can choose either of the two equations. I don't care which one you do. Unfortunately, neither of them is really that easy. But I'm going to do the top one just because the numbers are a little smaller and there's no negatives. But it's your choice for each of these. Sometimes you'll have one that has much lower numbers. Other times you'll have ones that have decimals, which is even worse. But choose either one. I'm going to choose the second one, which is the 3x, or the first one, excuse me, the 3x plus 4y equals 8. All I'm going to do is substitute in 2 for y. When I do that, I end up getting 3x plus 8 equals 8. This one's really nice because I'll actually find that I end up getting 0. Remember, 0 divided by 3, 0 divided by anything actually is going to be 0, so my x is 0. So your answer, you can either write it as x equals 0, y equals 2, or you can just write it as 0, 2. So for this problem, I would like you to please pause and try it on your own. So what we're going to do is we are going to add straight down. We'll find out that the negative 4y and the 4y cancel out. 6x minus 3x gives me 3x. 14 plus 1 gives me 15. When I solve for x, I get x equals 5. The last thing I need to do is substitute the 5 back into either equation. Neither of these equations is spectacularly great, but I'm going to go ahead and just use the first one. If you want to do the second, go for it. I'm going to end up getting 30 minus 4y equals 14. If I subtract 30 from both sides, I end up getting negative 4y equals negative 16, which gives me an answer of y equals 4. So my answer for this one is going to be 5, 4. So next one is going to be a little bit harder. There's just going to be an extra step. So if you remember from the previous slide, we need 3 things. We need everything lined up, which in this case they are. We need the same coefficient, and we need the opposite sign. So you'll notice that we meet 2 of those criteria. We have everything lined up, and we have a 6 in front of the y's. However, they are not the same sign. So what we're going to have to do is we're going to have to change it so that they are not opposite signs. We're going to have to change it so that they are. They're the same sign right now. So what I'm going to do is I'm going to multiply one of those 2 equations by negative 1. I don't care which equation you do. If you want to do the bottom one because it's on the bottom, that's fine. If you want to do the top one because the numbers are smaller, that's also fine. But I don't care which one you do. I'm going to actually do the top one. That one is going to end up being easier in the end. But if you do the bottom one, you'll get the same thing. So when I multiply that by negative 1, I have to do everything there by negative 1. So it's going to be negative 5 minus 6y equals negative 4. The other thing I want you to always remember to do is just rewrite the other equation near it. The big mistake I notice people making is that they add together the same equation and they end up getting a weird answer that doesn't work out at all. So it's always good just to rewrite it. I know it's extra writing, but it'll pay off in the end when you get it right on the test. So then you're going to add straight down. Negative 5x plus 7x is 2x. Negative 6y plus 6y is going to cancel out. I bring down my equals. Negative 4 plus 8 is 4. My answer for x is going to be 2. Last thing I need to do is substitute the 2 back into any of the equations I have. So I can choose the 5x plus 6y equals 4. I could choose the negative 5x minus 6y equals negative 4. Or I could choose the 7x plus 6y equals 8. I don't care which of the equations you choose. You can actually choose this one, or even the one that you changed. However, usually the one that you changed is harder. So I would go for whichever the original ones is easier. In my opinion, the top equation is easier because the numbers are a little bit smaller. So let's go ahead and put that 2 in for x. In the end, when I solve it out, I end up getting that my y is equal to negative 1. So my answer for this is going to be 2, negative 1. For problem number 4, please pause it and try it on your own. So for this problem, I'm going to try to eliminate my x's because I have a 7 in front of each of them. So the way that I'm going to do that is by multiplying one of the 2 equations by negative 1. I don't care if you did the top equation because in the end you're going to still get the same answer, so it's fine if you did that one. So I'm going to rewrite the top equation without changing anything, and I'm going to rewrite the bottom equation and make everything the opposite sign. So what's going to happen is my 7x and 7x are going to cancel out. Negative 2y plus 3y is going to be 1y, which I'm just going to write as y. 5 minus 4 is 1, and actually that's my y. That's all I get. If you did it by multiplying the top equation by -1, you would have gotten negative y equals -1, which is fine, because then after you divided both sides by -1, you would have gotten the same exact answer as I just got here. The last step you need to do is take one of the two equations and substitute the y back in. I'm going to do the top equation. So when I substitute that y back in, I get 7x minus 2 equals 5, which gives me 7x equals 7. So my answer is, for x, is also going to be 1. So my final answer for that problem is 1, 1. So now let's try one that's a little bit harder. For this problem, it's going to have a few extra steps that we need to do. So if you look back at the very first section that we wrote, the first problem we did, I said that in order to use elimination, you need to have your like variables lined up. So what we're going to do is we are going to try to move things around. And so I like the way the top equation is set up. It's set up exactly like the previous 4. So we're going to keep this one that I just put a star next to exactly the same. We're not going to change anything there. However, what I need to do is I need to get the bottom equation so that it's in the same form. So what I'm going to do is I'm going to move over that 7x to the opposite side by adding it to both sides. And I'm actually going to write it off to the side. I know I usually write things below when I'm adding, but off to the side is a little bit easier because then I can show what I'm doing step by step. So on the right-hand side, I am only left with a positive 30. The 7x's have canceled out. On the left side, I am going to have a positive 7x. I'm going to have a positive 3y. And now everything is nicely lined up. Luckily, the other two things that I need are also satisfied. So I have y's. I have a positive 3 and a negative 3. So now I can just solve this one out. So negative 3 and positive 3 are going to cancel out. On the left-hand side, I'm going to be left with 16x. The right-hand side, I'm left with 48. Then I'm going to divide both sides by 16, which gives me x equals 3. Once again, I can substitute the 3 back into any of my original equations. I can do it with the one with the star. I can do this one over here that I just gave a star to before I changed it, or I could do the one after I changed it. And actually, I really like the way that the first one before I change it with the purple star is. The reason is because it's almost all solved for y except for one thing, so I'm going to take that one. However, if you don't like that one, if it looks weird to you, that's fine. You can go ahead and use one of the other equations. You can do the top equation if you want to. So I'm going to get 3y equals negative 7 times x, which is 3, plus 30. That gives me 3y equals negative 21 plus 30. Or 3y equals positive 9. In the end, I'm going to divide everything by 3. I get y equals 3. So my final answer is going to be 3, 3. So this is our last problem. What I would like you to do on this one is pause and do it on your own, please. Okay, so this one might be slightly harder than the previous one. However, I'm still going to line it up a similar way. The top equation is going to stay exactly the same. I'm not going to change anything. The bottom equation, I'm going to keep the 6 in the same place. I'm going to keep the 5y in the same place, but I'm going to move over this 4x. The next thing I'm going to do is I am going to rewrite it. The 4x is negative. Keep it negative. Don't lose that minus. The 5y, there's nothing in front of the 5y in the beginning, so you can write a positive if you want to, a plus if you want to, but make sure that you keep it as positive 5y. Then we have that it equals 6. So then we're going to solve this out in a similar way that we did numbers 3 and 4. You'll notice that we have our 5s with our y, which is really nice. However, the 5s are the same sign, so we have to change it so that one of them is different. I'm going to choose the bottom one. And what's going to happen next is my two new equations are going to now be 2x plus 5y equals 12. You don't change anything with the first one. Bottom equation is 4x minus 5y equals negative 6. Then I end up getting 6x. 5y minus 5y is going to cancel. I get equals 6. That gives me x equals 1. So now, you are free to choose any of the equations that we've written out in order to substitute the 1 back in. I personally like the second one before I changed anything, so I'm going to use that one. But once again, you should get the answer if you use no matter which equation you use, unless you made a mistake. So I'm going to get 5y equals 4 times 1, which is 4, plus 6. Or 5y equals 10. That gives me y equals 2. My final answer is going to be 1, 2.